So 5-3 day 1, we are going to still continue solving systems of equations, but today we're going to learn a strategy called elimination. I think you're going to like it a lot better than substitution. Substitution is tricky. Yeah, it's a lot easier. So, solving systems of linear equations by elimination. Bless you. What we do in a strategy like this is you add or subtract the equations to eliminate one of the variables. When I say eliminate, what does the word eliminate mean to you? Get rid of. It's gone, right? So basically, we try to get something to cancel out, okay? So think of things that cancel. Like when you add or subtract. Yeah, well, you can divide things out for certain things. With this one, we won't have to worry about any division. But when you think addition and subtraction, what would cancel out a positive 5x? A negative 5x, right? Things that have the same number but the opposite sign. So what would cancel out with a 2? A negative 2, right? What would cancel out with a negative 7? A positive 7, right? So those are things we're looking to cancel something out, get rid of it, make it 0. Right, yeah. So then step 2, we solve the resulting equation, maybe do your 2-column method, things like that. Then you substitute the value or the number from step 2 into one of the original equations and solve for the other variable. So that part's still the same. When we find x or y, you still got to take it and plug it into one of the original equations. So that process is still the same. So best way to learn this is to just try it out. So if you take a look, the first kinds we're going to do are ones that are kind of set up nicely for us. They're already going to have opposite values, like a negative 5 and a positive 5, or a negative 2 and a positive 2. So our systems of equations, you're going to notice they're set up a little differently than they were with substitution. When it was substitution, wasn't there normally a y equals? And you don't have that here, right? That's a good way to decide which strategy works best. If you're given a problem that looks like this, don't try to do substitution. It's a huge pain. We don't even worry about this with substitution. You see something set up like this where your x's are lined up, your y's are lined up, your numbers are lined up, do elimination. Now, our top equation is 6x plus 3y equals 15, and negative 6x plus 4y equals 6. We want to look and see if something here would eliminate. Now look, compare the top equation to the bottom equation. Do you guys see anything that would cancel out with each other? Exactly. In the top one, we have a positive 6x. In the bottom one, we have a negative 6x. Right here. You guys see that? Yeah. If I added those, wouldn't they cancel? Yeah. This is perfectly set up for us to do elimination. So our first step in this process is actually done. We have found something that will eliminate. Now kind of step 2 is actually eliminating it. What you do with that is add or subtract the equations. Typically we try to add because subtracting kind of is a pain in the butt. So what we're going to do is, you guys remember when you had to, way back in the day, when you had to like add numbers vertically? Like you'd have 532 plus 37 and you had to go through and add it vertically. This is kind of, back in the day, this is kind of similar to that. We're going to actually combine these vertically. So what we're going to do, I'm going to put a plus sign out here just so you guys can kind of see what we're doing. And then I'm going to put a bar underneath. This is just kind of an organizational thing. Now you're going to go through and from left to right, we're literally going to add things together. 6x and a negative 6x. What's going to happen with those? They cancel. They become 0. We're actually not even going to bring down the 0. We don't need it. It's just distracting. Then 3y plus 4y is what? 7y. Equals, and then 15 plus 6 is 21. Now we have 7y equals 21. Could I continue to solve for y now? What could I do? Yeah, divide both sides by 7. Yep, 21 divided by 7 is 3. Isn't that so much better? Yeah, I know. I wouldn't even teach you substitution if I wasn't required to. So now I know what y is. Now to find x, we do the same idea that we did last time. You're going to take your new number, and it's a y, so I can plug it into either of my first equations anywhere where I see y. Do I care which one you use? No, you are allowed to use either. I would use whichever one looks easiest to you. Now, I would also go with the top one as well. I would look for which ones has smaller numbers, which ones have less negatives, things like that. So we're going to take this y, and we're going to plug it into our top equation where we see y. So just to make sure we're staying organized, I'm going to rewrite this equation. It's 6x plus 3y equals 15. And now I'm going to take my y and I'm going to replace it. So I'm going to put my open parentheses, right? And what are we plugging in for y? 3. Yep. And now let's go through and simplify. What would be our first step as we simplify this? Yep. Distribute. 3 times 3 is 9. So 6x plus 9 equals 15. Then what would we do? Well, so the 9, does the 9 have an x on it? No, so you actually can't add those. We want to get rid of that 9, actually. Does anyone remember what we would do with it? Yeah, aren't we adding 9 right now? Technically, doesn't it need to move over? Yeah, so we would subtract it. You could do your 2-column method if you want, or think of it, yeah, as subtracting 9, either way. So then you'll have 6x equals, and what's 15 minus 9? 6. And then what would our last step be? Yep, divide both sides by 6. And what is 6 divided by 6? 1. You're thinking minus. 6 minus 6 is 0. Good. And then who remembers how you write your final answer? Yeah, we already did that. We have to just like write it as a what? As a point. Yeah. Yes, it's still xy. So we're going to write this as a point, which is 1, 3. And that's our answer. Isn't that easier? Are you awake? I like these ones better, personally. Okay. All right. Do we all have that down? Number 2. Okay, so now number 2. First thing, look and see, do I currently have anything that will eliminate? When we get into harder ones, we'll have to make it. And that's okay. It actually doesn't matter if it's in the middle or not. Right here, I have a positive 3y and a negative 3y. Will those cancel with each other? Yeah. Absolutely. Remember, you're looking for the same number, but with different signs. So now we're going to do our same exact process. We have something that'll cancel, so I'm going to just go through and add vertically. Good thinking. All right, so negative, and remember, do we want to guess what our numbers are? No, we need calculators if you don't know, so feel free to go grab one. Negative 9x plus 7x. What's negative 9 plus 7? Negative 2. So that's going to be negative 2x What's going to happen with the positive 3y and the negative 3y? Yeah, they're going to cancel. I would just cross them out. Bring your equal sign down. And what is negative 9 plus 13? Yep, 4. Now, what do we do on both sides? Yep, we are going to divide by negative 2. Good. And be careful. I know we sometimes make silly mistakes with our positives and negatives. What is a positive divided by a negative? A negative. And then 4 divided by 2 is 2. So this should be negative 2. Writing this down, Corey? Okay. Now I have what my x is. How do I use this to find y? Yep. I'm going to plug it in. Does it matter which equation I plug it into? No. Pick whichever one looks easiest to you. Bottom one sounds good to me. Yeah, a few less negatives happening, right? So we are going to now take this value and we are going to, that's not what I meant to do. We are going to plug it in for one of the x's. So we decided to use the bottom one, so that's what we'll do. All right, so I am going to write this with my open parentheses. Remember, we're replacing x, right? I highly recommend that you do this step, that you do your open parentheses, plug in the right number. So we're going to have 7, and instead of my x, I'm going to put my parentheses, minus 3y equals 13, and then what number am I plugging in there? Negative 2. All right. Somebody at home, what do I do now? That's okay. They couldn't hear you anyway. Good, Asia. Yes, I need to distribute the 7 with the negative 2. That's going to give me negative 14 minus 3y equals 13. Now I need to solve. Could you do your 2-column method with this if you want? Absolutely. Do you guys feel more comfortable doing the 2-column method? Okay, or if not, you can always just add your 14 over, okay? So do what feels more comfortable to you. Which way do you guys prefer? Yeah, this one, there's not a lot going on. Now with this one, you have a negative 14, right? So if you move a negative 14 over, it needs to, what? Become a positive. So we're going to add 14 to both sides in this one. So add your 14 to both sides, or do your 2 columns. That's going to give you negative 3y equals, what's 13 plus 14? 27. And then what do we do from there? Divide by negative 3. And then class, a positive divided by a negative is a negative, and 27 divided by 3 is 9. So y equals negative 9. And then someone I haven't heard from yet. How do I write my final answer? Aiden. Yeah, negative 2, comma, negative 9. Good. How are we feeling about this? Pretty good? Okay, good. People at home, how are we feeling about this? Okay, it'll take a little bit. Which is there a certain part that's throwing you off, Dallas? Mm-hmm. Like when we took our negative 2 and you plugged it in? Okay, so for that part, Dallas, you can pick, so we know what x is, right? We just got to find our other variable. So if you look up at your top equations, don't both of the equations have the letter x in them? So basically what we're doing is we're just picking one, either one that you want, and you're going to put negative 2 where you see x. So we're literally just taking this 2 and plugging it in where x is. That's where that 7 times negative 2 came from, because see this bottom equation, isn't it 7 times x? So we made it 7 times negative 2 instead. Then minus 3y equals 13, and then we just simplify our equation. Okay, I know that part can be a little bit tricky, but is the first part making sense at least? Okay, the second part might just take a little practice, you know? Nick, I saw that you just messaged me. I'll mark you as present. All right, let's try this again. How many of these are on this page? Okay. We'll see how many I want to do at least 1 or 2, and then I kind of want to look at, if we have time, a few of the next one, and then I'll think of some extra way for us to practice this tomorrow during the e-learning day. Everything on this front page should be set up correctly, yes. Well, the other side is slightly different. Oh yeah. I wanna look at number 3 together, and then I might have you guys try 4 on your own, and then we'll go to the back. Because number 3, take a look at 3. We have negative 2x plus 4y equals 13, and 2x minus 4y equals negative 20. Anyone notice something about this one? Both of them are going to cancel. That's why I want to make sure we look at this. Because sometimes weird stuff happens, but don't we sometimes have things with no solution or infinitely many solutions? When everything cancels, one of those situations is going to happen. So yeah, if you notice, here the x's match and the y's match. So when you go through and you add this, what's negative 2x plus 2x? 0, it's gone, right? 4y minus y, what's going to happen? It's gone. Is there anything left on the left-hand side? No, so we're going to just put a 0 because there's nothing else to write. Yeah, put your equal sign, and then Alex, 13 minus 20 is negative 7. Does 0 equal negative 7? No, so who remembers what we say when we get something that's not true? No solution. Good. What do you say if you get something that is true? Very good. Infinitely many solutions. All right, I want you guys to try out number 4. All right. So make sure you follow along, check it, make sure you got it right, fix anything that is wrong. Mr. Sanders, what letter is going to cancel out on this one? 10x and negative 10x, exactly. Those are going to cancel. And then we need to combine our like terms. 8 and what's negative 4y plus 7y going to give us? 3y equals, Lynn, what's 2 minus 26 going to give us? Negative 24. Olivia, what do we do from there? Yep. Divide both sides by 3. Now here's the place where I saw a lot of mistakes. What is a negative divided by a positive? A negative. This should be a negative 8. So for y, you should have gotten negative 8. Someone at home, now that I know y is negative 8, what do I do with it to find x? Hannah, any ideas of what I need to do with y now? No? Anybody? Aaron? Are we awake? Are we there? Can we hear me? Well, so I know that y is negative 8, right, Aaron? So I want to use y to find x. And if you look at your equations up here, don't they both have y's in them? So where do you think I should put the negative 8? Where it says y. Does it matter which equation I pick, Aaron? No, which one looks easier to you? 7y? Okay, we'll use that one. Should you get the same thing if you plugged it into the top one? Yeah, shouldn't matter at all. Okay, so let's try this out. you would have negative 10x plus 7 times negative 8, because instead of y, we're putting negative 8, equals negative 26. If you use the other equation, that's totally fine. And make sure you're checking this and not on your phone, please. But you should get the same answer no matter what. So negative 10x minus 56 equals negative 26. I'm going to add over my 56 to get 30, and then divide. Everyone should have gotten negative 3 for x. If you had plugged it into the other one, which probably most of you did because the numbers are a little smaller, let me show you over here what you should have gotten. You would have had 10x minus 4 times negative 8, which is 2. This is if you use the other equation. What's negative 4 times negative 8? Positive 32 equals 2. You would have subtracted over your 32 to get 10x equals negative 30, and then divide, and you should still get negative 3. So shouldn't you get the same thing no matter which one you pick? Yeah, shouldn't matter. Okay, so your final answer is the coordinate point, negative 3, negative 8. I think we have time to talk about one other thing on the back. Oh yeah, I just want to show you guys where to find it. It's really fast. All right, so on the back, and so tomorrow, guys, for your e-learning day, I think I'm gonna do a few more of these in a video. Okay, so you can have your notes out. We'll do a few more of these in a video, and then we'll do a little activity with it, kind of like the Google slide from yesterday. So now what's just slightly different is what if you have the same values, like a positive 5x and a positive 5x? Will two positives cancel? No. So we're going to have to do something a little extra. You're going, if you have to blank, make sure all yours, if you have to subtract, what we're going to have to do with these ones, if you take 5x plus 5x, that won't cancel, right? But what if you do 5x minus 5x? Will that cancel? So if your signs aren't the opposite, you need to subtract. You basically need to make it be the opposite. So if you have to subtract, make sure you make all your signs the opposite. Sorry, I forgot how to read there for a second. Tell me in a second. Okay, so here, take a look at number 5. Do you guys see something that matches? Okay, yeah, 15 and 15, and then, but look at the variables like x's and y's. Yeah, the two 5x's. Normally, we want opposites, right? We want a positive 5x and a negative 5x, but this one's not giving that to us. It's giving us a positive and a positive. If we add those, it's not going to work. But what if we subtract them? Then it will work. Now, here's the thing about subtracting, though. If I subtract the 5x, what do I need to do with my negative 9y? Why? Technically, don't I need to subtract a negative? And what happens if you subtract a negative? It turns into a positive. And what am I going to have to do with that second negative 15x? Make it a positive. You basically want to reverse all your signs for one of them, okay? I always do it with the bottom one. So if you subtract, you got to make sure you make all your signs the opposite. I made the first one a negative, then switch the second one to a positive, switch the third one to a positive. Now, does this look the exact same as what we were doing before? You got a 5x and a negative 5x, and we can go through and do that. No, it still cancels out. So 5x and negative 5x will still cancel. 3y and 9y will become 12y. And negative 15 plus 15 is 0. Then what do you divide by? Divide by 12. And what's 0 divided by anything? 0. Not necessarily, 0 is still a number. Yeah, because not everything has to cancel out for that to happen, Hayden. Now that we know what y is, how can I use y to find x? Plug it in. Does it matter which one I plug it into? No, but what letter do I need to plug it in for? For y. Now, here's the thing, though. I'm going to go ahead and say it does kind of matter in this one. I would plug it into the top one. Does anyone know why I'm going to pick plugging it into the top one? Well, because I haven't messed with the top one, have I? The second one, didn't we like move some signs around and we did some stuff to it? So I'm gonna go with the top one on this one because I haven't changed anything about it. So I'm gonna plug this in here. 5x plus 3 times 0, because we found out y was 0, equals negative 15. So that'll give us 5x plus, what's 3 times 0? 0 equals negative 15. So does the 0 really matter? No, it's just 5x equals negative 15. And divide to get negative 3. I know I went through that one kind of quickly because we're short on time. So you should get negative 3, 0. Tomorrow, during your e-learning day, I am going to record